My name is Naveen Kumar, and I'll be dealing manufacturing and industrial part for you guys for the mechanical engineering syllabus. So my brief intro is this, very short intro. So I did my bachelor's from IIT Kharagpur from mechanical engineering, and I did my master's from IIT Hyderabad as manufacturing as my specialization, and then I went on to uh, uh, you know join in a PSU. I worked for 2 years, which is in Ranchi. Um, uh, there are some things. So I was interested in research. So then I came back to again academia. Joined a PhD in IIT Bangalore in 2016. It is still continuing. I'm towards my end because it's got delayed because of some COVID and all these things. And I have 6 years of experience in GATE, especially manufacturing and all these things across different institutes in India. Okay, fine. So you all know this. Most of you, know this GATE. So generally, people ask you, "I have written GATE. Are you writing GATE? GATE, 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 GATE." So what is GATE? GATE is nothing but Graduate Aptitude Test in Engineering. So hope, even though if you know, and I'll give you a small introduction about this, what is going to be and what is the use of writing GATE and what are the uh, uh, benefits that you're going to get from GATE. Okay. So basically GATE is organized by Indian Institute of Science and Indian Institute of Technologies. So every year, one of the institute will be the organizing committee, and they'll be setting up all the hall tickets, your question paper, your arrangement of seating arrangement, where is your examination center and all. So what you can do with this GATE? So you can the GATE score what you're getting will be having a good weight, because wherever you go after your mechanical, maybe if you're from mechanical, if you're from different engineering, it's fine. But the GATE score of a candidate, which reflects a reflective, relative performance of the candidate. Okay, so it means that, so if you want to go into MTech program, or if you want to go into a PSU in the sense it's a public sector unit, you can decide whatever you want to do, but you have to clear GATE with a very good score. Okay, so what you can do, you can do MTech research in IISc, IITs, and NITs. And then, so obviously, if you're doing higher studies, you'll be getting paid according to the domain and according to the degree that you are choosing for. So if you're choosing for MTech, then it will be 12,400 rupees that you're getting per month. And if you're doing direct, there is a provision called direct PhD. In the sense, no need to do any MTech after BTech. You can directly jump to PhD. It's called a direct PhD program. So even if you join, you can go for direct PhD program in IITs and NITs and IISs, and then you can get a stipend of 35,000 per month. Okay, which is of course provided by the MHRD. Okay, and then so if you can have a good score, so let's say, sir, I mean, we have PSUs are offering through the GATE score. Why should I join MTech? And one advantage of it is that you get MTech degree or a PhD degree, and of course the placements that are coming up in the these institutes, especially IITs and IIScs. So what happens? IISc, what happens is that you get a very good package at the end of your completion of your degree. Okay, like it varies from the minimum of 6 lakhs to 30 lakhs. Now I think the minimum is 8 lakhs. This was very long back. So 30 lakhs, you can go up to 40, 50 also. That is like based on your, the performance in your study here in IITs and IISs. Okay, fine. So having said this, we can even use this GATE score for having admissions abroad in, like very neighboring countries like Singapore, Malaysia, or if you want to go to Europe countries, you can go to Europe countries as well. Okay. And as I already told you, most of the guys are preferring to write GATE for joining PSUs because of their lucrative packages. So what are the PSUs that are welcoming the GATE score, or they're using the GATE score as the essential requirement, right? So what are those? Those are like ONGC, Oil and Natural Gas Corporation, NTPC, GAIL, HPCL, PGCIL, BHCL, BSNL, HPCL. There's so many. You keep on, you name it. We have so many organizations which are allowing, this score for their screening purposes. Okay, means that they'll be screen you through the score, and then they'll be organizing some group discussions and a personal interview. Based on that, there'll be weightage for each of them, and they'll be selecting you based on your performance. And coming to GATE 2022, that is going to happen this year, and in the second or third week of February, is organized by IIT Kharagpur, and the next year 2023 is going to be conducted by IIT Kanpur. It doesn't mean that IIT Kharagpur this year is going to prepare the question paper. It means that it's an organizing committee. In the sense, it will be organizing your all the details. It will take your details. It will give you the hall ticket. It will give you the result. All these things. So a question paper will be prepared by all the IITs and IISs together. Okay, fine. So, and as I told you, you can apply to these specific universities if you have a GATE abroad. I mean, you can, if you have a very good GATE score, and you can go abroad as well. That's what I said, right? Fine. So, how will be the the GATE mode of examination? So, as you know, the examination for all the papers will be carried out online, of course. That is called computer-based test, and where candidates will be shown the questions in a random sequence. Random sequence in the sense, like first 15 questions will be of aptitude, and the next will be on your domain, whatever domain that you are selecting for. And then the candidates are required to select MCQ types, and MCQ or MSQ. This is a new one they have introduced in 2020 year. That is multiple select questions. In the sense, like it's not only option A or B or C or D is the answer. Anything. It can be permutations of anything, combination of anything. It can be AB, it can be ABC, it can be ABCD, it can be CD, anything. So this will screen more filter the persons who are not having much concept, or like maybe they are just preparing for a short term. So long term preparation is very essential. That's the reason why they are opting for this kind of screening procedure. Okay, and then of course there are some numerical type questions where you should be able to type the answer, in the sense like you should be type the numerical answer. Let's say if your answer is 34.5 kilonewtons, let's say. So then you have to answer the you have to type that 34.5 to something like that. You have to have 2 decimal precision. Okay, and of course you have 3 hours of window for completing your question paper. And then let's see the marking scheme. Obviously, as I told you, there will be 15 marks for the general aptitude, and then okay, as in all papers you can see, there will be some 65 questions as of your total questions, and then which will carry 100 marks, of course, of which you have 10 questions, okay, which will be weighted to the general aptitude, and the next 55 questions will be weighted to the mechanical engineering domain. Okay, and you have 3 years of domain. Window. You have to complete the paper. That's it. Then based on this, you can see the papers, number of questions, and number of marks. You have 1 mark questions. You have 2 mark questions, and based it will be everything. Like you have some easy questions, tough questions, medium type questions. Everything will be spread across. That's it. So this is how you'll be having the exam pattern. Okay. And okay, fine. Till here, it is a general discussion that we had, and now we're going to enter into the syllabus part of mechanical engineering, and especially my syllabus, like what I'm going to discuss, what I'm going to deal especially. Okay. So here we have materials, manufacturing, and industrial engineering. Okay. So here there are specifically we have engineering materials, casting, forming, welding, joining process is also known as welding. Then we have machining and machine tool operations. We have metrology and inspection. We have computer integrated manufacturing. Okay, so all these things comes under the what you say, let me take my cursor here. Okay. So these two parts, this page contains these two parts. Okay. That is your engineering materials, casting, all these things. And the next part is this, that is your industrial engineering. This is your industrial engineering. Okay, fine. So if you see industrial engineering, it's mostly, you can see this kind of a management techniques, production planning and control, inventory control, operations research, but mostly will deal in the mechanical and manufacturing perspective, not at the business perspective. This, you can use all these things in the business perspective as well, but mostly we'll be using in the manufacturing side of it. Okay, but the principles are very common. Mostly management guys will read this kind of stuff during their BBA or MBA. Okay, so let's not go very deep into the syllabus, but I'll be having some important, I'll be discussing some important topics. Okay, as we move on with the slides. Okay, so this is a pretty vast, big syllabus that I'm going to deal with you guys, because if you, okay, let me go to the weightage. See, that's what where I will come into picture. So if you see the previous 2012 to 2020, I didn't have the statistics of 2021. I didn't get that. If I got, I would have added here. But anyways, so we had past 9 years of weightage for each subject in GATE for mechanical engineering. So if you see, basically the highlighted one, that is the manufacturing part, that is this syllabus, this whole page here is contributing 16.5%, in the sense 16 marks in 2020. So mostly if you take the average, it will be around 16. So 16 marks are minimum from manufacturing engineering. It might be increasing, it won't reduce. Okay. And the other thing is industrial part, and that is from this page of syllabus will be having what you say 6.5. You can take it as 7. Here you can take it as 17. You can take it as 7, and you add 17 plus 7. It is 24 marks. Okay, approximately 25. You say, let's say. So 25 marks, in the sense out of 100, 25, 1/4 of the paper is from these two parts. It's very, very important, and it's very easy. It's very easy. Why? Because it is not having any connection with any of your what you say topics. Let's say if you are dealing with fluid mechanics, obviously you have to have good command on first chapter so that you will be able to understand the last chapter. But here it's not like that. Everything is individual. Let's say if you're taking casting, that's an individual procedure. If you are taking forming, that's again an individual procedure. Machining, individual. Like that, everything is having their own procedure. But the problem here is you have to have good basics in basic only. Good basic in what you say the fundamentals of little bit of math, little bit of fluid mechanics, little bit of heat transfer and strength of materials. Basics, I mean, not advanced level, basics. If you know those basics, that's enough. That's enough. And basic maths, you'll be able to easily crack this 25 marks without any problem. If you attend all the classes and ask all the, clarify all your queries and questions, and then I guarantee you, out of 23 to 25 marks, you will be damn sure that 20 marks will be, I'll guarantee you 20 marks if you're attending all the classes and querying, if you are solving all the problems and taking all the test series and keep track of your time and all the things. If you are having very good, I'm not getting the word, but you are very sincere about this, then I'm guaranteeing you 20 marks will be sure from my side. Okay, this is not overconfidence. This I'm telling you sure. It's very easy. Okay, next. So what are the books? People generally ask me, so what are the books that I have to follow? Generally, I expect you do not follow any book. These books are only for reference. Don't keep on starting from first page, go to index and see, and don't read like a novel. There is no use. For GATE, you have to be very smart. Okay, so what is required, that is enough. Don't go, if you're reading this book, there might be syllabus which is out of GATE, and you're reading it and you're wasting time. Instead of that, you can solve some other question paper, or instead of that, you can solve your concentrate on your weakness. But anyways, but obviously you should not completely rely upon your teacher, because he or she might be making a mistake, or maybe having some problem in teaching some concept, or else you are not unable to understand that concept properly. Then obviously books will be very in hand. So these are the wide variety of books for all the manufacturing part. So I prefer this book. I prefer this book because this is a very basic book that every BTech or engineering student has to undergo if he or she is from mechanical engineering. Okay, engineering. Okay. So this is what is written by Amitabh Ghosh and Ashok Kumar Malik, and these both guys have worked in in IIT Kharagpur and IIT Kanpur as their faculties members. And here you have manufacturing technology by P.N. Rao. We have this welding by R.S. Palmer, and this is another very good book for manufacturing is this. This is given by the Kalpak Jain. Okay, and casting is written by this Rosenthal and all. But anyways, this is only for handy reference. It's not for you're doing research. You're not doing any research, right? You want to crack the exam. I don't know how. I will give you 3 hours. I will give you 65 questions. Do it. That's it. Your lifetime. Once you clear, you don't know. You can do wonders. I'm telling you. You have so many options. You have so many options. One gate exam is having a very very high prospects. I'm telling you. Okay. Next, for books for industrial engineering, as I told you, you have OP Khanna, you have this Taha. There are so many books around, but you can follow anything. But generally, I follow this for my understanding. If I miss some things, if I don't know, if I'm having some conceptual issues, then I'll be following this. But anyways, it's not only books that you have to follow. You can follow any online blogs or maybe YouTube videos. Anything is fine, but do not waste much time on these things. That's it. Okay. Next. So let me enter into the manufacturing part here. So till now, am I clear? It's only a one-side talk that I've been giving from past 20 minutes. So can anyone talk and tell me how? I mean, what's your stand on? Where are you from? I have only 1, 2, 3, 4. I can just talk one-on-one. So there is Aditi, Arul Kumar, Nandan, and Santosh. So can you guys speak up, or maybe you can put a chat? Where are you? I mean, what is your background, and what is your current status like? Are you still pursuing your BTech, or maybe you have completed it and you are doing job? What is that? Please, guys. Hello. Okay, Nandan, Bangalore, MTech last year, MEC last year. Okay, you completed it. Okay. What about this? Okay, last year, Nandan. Oh, no, it's not Nandan. It is Santosh. Sorry. What about other guys? Okay. I just graduated.
Yes, sir. This is Arul Kumar.
Arul, yes. Hi, Arul.
Yeah.
Yeah.
Yeah. I complete my BTech in the year of 2015 after
Oh my God.
entering
Oh,
into
yeah.
the job. Yeah.
You're
Now
doing
I'm,
job. Where are you doing,
yeah.
sir?
Sorry.
Where are you? Where are you doing job?
That is on private concern in Bangalore.
Okay, fine. So there is one more person who has to respond. Aditi Pati.
Yes, sir. Hello, good morning, everyone. This is Aditi. I'm
Yeah.
from Hyderabad.
Okay.
I completed my BTech in mechatronics engineering, and I'm
Okay.
working for Amazon right now. So I completed
Wow.
BTech quite some time ago. I want to get back to doing MTech.
Okay, fine. Very nice. Good. So I have seen wide varieties. One is from doing Amazon, another is from some private firm, and another is still pursuing BTech, and in the last year, of course, and somebody has just graduated. See, there are wide variety of people here around here, and fine. So good that everybody responded. So don't worry. So even though you just graduated, even though you have lost your touch with your basics and all, I'm here to help you. The only thing is that please do not hesitate to ask, interrupt me and ask the questions. And also you have to do lots and lots of hard work, because some people who have lost touch will be having some hard time to come back. I know that because I've seen so many people around. So, but initially it might be a trouble. Please don't give up. You'll do well. Let's proceed with the manufacturing part. I'll just give a very brief intro. I won't be, dwelling into some formally and all the things that we'll be doing anyway. Just I'll show you the glance of it, like, some gist. That's it. Okay, fine. So what is manufacturing exactly? So manufacturing is like people say so many definitions around, but what I like is very simple, layman definition. I don't want to get complicated. So the layman definition is nothing but converting raw materials into valued products. That's it. I have some raw material. You give me a valued product that I can use into some day-to-day life. That's it. So how are you going to do, right? So there is a very big chain of processes that we are having in the manufacturing industry. First you have to design it, of course, right? First you have to design it, right? You design it. So design guys, what they'll do, they'll design it. They'll do some FEM simulation, CFD simulation. But the main result will come from manufacturing. You're designing, it's virtual. Where is the physical prototype? You're designing, it's virtual. Okay, that guy's a very, very big, great designer. You are a great designer only when you are designing a product that is when manufacturable. You have to produce it. It should be able to get produced. Some high funda stuff you're designing it. If you are unable to produce it, then what is the use, right? So that is the reason why you have to concentrate on manufacturing. I don't know why India is very, still in the, progressing state. It has to progress a lot. See the other Eastern countries like China and Japan and Korea, they're very fast. Okay, but anyways, let's not go into that. So next, what we'll do once you design the product, let's say if you're going for the strength of materials. Okay, so what you do is strength of materials, you do all stress, strain, movement, that movement, this movement calculations, and then you'll size the material. Size the material in the sense, let's say a simple example. So you have a chair. Let's say you have a chair, and you want to produce a chair. So before that, you have to design the chair, right? So before designing, what you do the analysis, like, okay, who is going to sit in this chair? Is it a kid? Is it an adult? Is it an is it an old elderly person who is sitting? So based on that, you will design your base, armrest, legs, and all. But you design, but you take material. Which material you want to do? That is where the material selection will come. What do you want to do? You want to make a plastic chair, or you want to make a iron chair? You want to make wooden chair? What do you want to make? And now, once your material is fixed, now you keep your calculations ready. Okay, material is fixed. Young's modulus is fixed. Shear modulus is fixed. All materials are fixed. Properties are fixed. Using these properties, you size the material. What should be the length of the leg? What should be the base of the leg? And how much weight it has to take? All the things you'll keep, and you design it. Once you design it, the product has to be manufactured. So the product will be manufactured through sequence of process, right? So you have to have a raw material. Let's say if you see this example in the right hand side of your slide. What is that? You have some input and you have some output. That is a product. So what is the input? Input is nothing but obviously your raw material. Your raw material is very important, right? And then once you give the raw material, you have to have some machine, of course. You have to have some machine, right? And then you have to have some manpower. So these are basic requirements. Okay, of course, power and all you have to give. I mean, electricity should be there. That is different. But you see, M, triple M. These are very basic needs and very basic inputs that are required for a manufacturing process. Then once you give, then you have sequence of stages. First raw material, then you have to do casting and make some billet, and then how does this, what is there in the right hand side? What do you see on the right? What is the image of it? What is this? Anyone? What is this?
Bolt.
Anyone who can answer? Yeah, it's a bolt. Very good. It's a bolt. Very good. So how do you manufacture this? How do you manufacture this? Generally, you have a sequence of it. You have some kind of a billet. And how do you get this billet? this billet of some, let's say it's a mild steel. It's a mild steel material, let's say. And this billet, you have to get it from a casting. Where are you doing the casting? You're doing the casting in a foundry section. And where do you get raw material? You get more raw material from earth. You get raw material from earth. Then what you do? You process it. Metallurgical processing will be happening. Metallurgical processing, right? So I'm just making a shortcut. Sorry for this, but I'll write it clearly. Don't worry. So after that, what you do? You use some casting, or maybe some casting preliminary manufacturing things are castings, right? So here what you do? This has been obtained from casting, this billet. Now what you do? You have to remove this part of material, obviously, right? So how do you do that? How do you do that? Any guess? Anyone? How do you do that? I have to remove that, reduce the diameter till that point. I have to remove this part. Anyone? How do you do that? Any manufacturing?
And the CNC machines.
Excellent. Obviously, you have to use lathe. That is turning process, right? You have to use turning, right? So you do the turning, then you get this kind of a product, right? So let me see. You have this product, right? Now you have to have, what is this? What is this very specific thing here? What is this? Why it has been made like this? This one. What is that? There's a separate this thing. What is that called? Anyone? Why they made two lines here? It's not tolerance.
That is a thread.
Threading. Threading. Tolerance is mentioned something like this. They'll separately mention onto that by using this surface finish. They'll be having some symbols for mentioning the threading. Threading is the right answer. Aditi has answered it well. So you have to do threading. So where you can do threading? Again, you can use lathe machine for doing threading. So you can do the threading. Threading is done, right? So now again you can see there are some bolt. It is not completely circular. Bolt is like, if you see from top view, it is something like that. Am I right? It is something like that. So instead of having this thing, you have to remove that. So how do they remove this extra part? How do you remove this extra part? Anyone? The top, from this is a circle, right? If you see the view, this is a circle, but I want to remove this extra part. Bolt is something like that, right? So I want to remove that extra part. I'll show you that what you want to remove. So how can I do that? So I want to remove this green color part. Yes, you can use chamfering, you can use milling, you can use anything. You can remove it. Okay. So see, there are series of process. Casting, right? Casting. Then what you did turning, right? Then you did threading. Then you did what? Some milling, chamfering, whatever it is. Then bolt is ready. You can't change this order. Maybe some orders can be changed, but you can't go directly to threading before turning, obviously, right? You can't directly go to milling before turning. It's difficult, right? So that is the thing. That is the thing. So you have some series of procedures that you're going to do. That is called your process planning in the industrial. So how well, because it's not only one part. You're talking about a single bolt. There are some thousands, lakhs of products are being manufactured in a single manufacturing company in one day. So how are you going to organize all these things very effectively, cost effective, time effective, right? That is where the industrial engineering comes into picture. Okay, let's move on. So now let's go into some specific topics like casting. So as I told you, casting. What is casting? It's a very primary manufacturing, technique. You have to do casting. You have to get some basic billet or some kind of a raw shape, right? Some kind of a very well known. Maybe it can be billet, it can be a slab or something like that. So how do you make that? Or you can make it some parts also. Okay. So casting is nothing but, you see, the process of pouring molten metal into hollow cavity and allowing it to cool and solidify into desired shape. So what is that? There are some important terms here. What is that? First is molten metal. It means that you have to heat the material above its, what you say, the melting point. Then you pour. Where are you pouring? You're pouring into the hollow cavity. There is a hollow cavity, and where the hollow cavity is, you are making the hollow cavity by using some patterns, right? You use some sand, you use some patterns, you ram it, and all these things you might have done in your BTech days. Basically, I think in first 2-3 years of your BTech, you might have seen somewhere around, you might have visited foundry, and you might have done this mazdoor, this labor work, you might have done this. You have to do it. Then you make that hollow cavity of the desired shape that you wanted to have, and then you allow it to cool. Then of course it will get solidified. Then you get a desired product out of it. Okay. So then the solidified part is called casting. Okay, fine. So what are the industries that are going to use? You name it, so many are there. Automotive industry, cooker industry, aerospace, jewelry, everything. You see, this is kind of a very complicated object, you see. But this complicated object can be manufactured in a single go. Can you even imagine? Single go. Directly you manufacture. This is what? This is kind of a metallic mold that we have. That is called permanent mold. I'll be discussing this specific things in the lectures that we're going to deal. So metallic mold, reusability is there. Keep, pour, wait for some time, remove. This part is done. Paint it. Finished. Very fast. And this is what sand mold, and these are called temporary molds or expandable molds. And once you use it, you can't reuse it again. You have to discard these things, and again you have to assemble this. These are called sand molds. So all the things what you see here is your, the hollow cavities that you want to fill with your molten metal and solidify it. That's it. Very quickly can do this. So if you see, this is what is called sand molding. Let's discuss how this sand molding is being done. So if you see a typical sand molding, you might have seen this. How many of you have seen this? Anyone? How many of you have seen this? I think everyone might have seen the sand molding in their somewhere in your BTech days. Am I right? Right? Hello? Yeah, very good. You might have seen this. So yeah, good. Thank you. So what is that? You have some cope box, drag box. The bottom box is called drag box. The top box is called cope box. Then you have a pouring basin. You create this kind of entries, and specifically you put this in a specified geometry. Why and all we'll be discussing. Okay, it's called aspiration effect. To avoid aspiration effect, this sprue, what you're having, this sprue that what you're having here should be tapered. It should not be having straight lines. It should be tapered. Why you are going to make taper? There is a reason. Everything there is a reason. To avoid aspiration. What is aspiration effect? To avoid the negative pressure. Why negative pressure should not be allowed? Because if you are allowing a negative pressure in somewhere in the molten flow, then your casting will be having some defects of like gas flows and all this will be there. So you want to avoid them. And why this runner is there? What is the shape of this runner? And what is in gate? If you want to have a hollow section in your casting, how are you going to do that? Okay, guys, 1 minute. I just there's one small interruption for 2 minutes. 30 seconds. Please wait. I'm just coming back. Sorry for interruption. Okay, guys, I'm back. Okay. So if you want to have hollow section in the solidified part, then you have to use the core, right? So then there is a riser. Why the riser is important? So to know, one, you have to know whether this cavity is filled or not. Another, it has to compensate the shrinkage compensate so many allowances that you have to provide the onto the pattern. Okay, so like that there are so many things, okay, that we are going to discuss. So then once you are done with the bottom box and top box, you clamp them and then you pour it, and this is how it is being done. And then you'll provide some venting holes to make sure that the gases that are created during the pouring will be escaped. Okay, and then once you're done, you may get this kind of a product. But what is useful? The useful product is only this, the boxed one, this one. And this you discard, this you remove by some technique called fettling. Okay, so that is how the casting is being done, sand casting. Next is metal cutting. As I told you, we have seen already. We have seen lathe process. I mean, so many ways, so many basic operations are done by the lathe machines. But it's not only lathe. There are so many things. So there are some single point cutting tools, multi-point cutting tools, finishing tools. So many are there. Okay. So basically, machining is a broad term to describe removal of material. So this is a material removal process. In the sense, here casting is what? Material addition process. There is a simple hollow cavity here. You are pouring the material and you are solidifying it. You are adding the material, right? Here it is. Once the material is there, you are removing it to make it to a different shape that you want to have, size and shape. Okay. So traditional machining is mostly based on removal of material using tools that are harder than the workpiece. So from now we'll discuss two things. One is workpiece like this. This is the shortcut for workpiece, and another is tool. Workpiece is the material that you are going to size and shape, and tool is the material that you are using on workpiece so that you can cut it. Okay. So what are the different single point, multi-point cutting tools? So this is a lathe cutting tool. So if you see, this is called insert. This is called insert. So it is having some different specific geometries on that insert, so that your cutting operation is done with minimum power. That's it. Okay. And then you have drilling bit, right? You have this drilling bit, and then you have your milling cutter, right? And then you have a grinding wheel. All these things are different. So lathe is having single point cutting. Drilling bit, multi-point. How many cutting points are there for drilling bit? Anyone who can answer this? Don't worry if you're not unable to answer. I'm just asking if somebody is knowing this answer. How many cutting points are there for drill bit? Anyone? Cutting points are nothing but the cutting actions are happening at these points. Anyone who can answer this question? How many cutting points are there for a drill bit? Anyone? Okay, the answer is 2 for this. There are two cutting points for this. And milling cutter can be having any cutting points and cutting points. You can fix any cutting points. So all these things are cutting points. 1, 2, 3, 4, 5, 6, 7, 8. There's so many cutting points. In grinding, it is also multi-point. All the abrasive materials that are stuck onto the grinding wheel are cutting points itself. Okay. Then this is a simple question that I want to solve for the sake of solving. Anyways, I didn't discuss any concept here. Simply for the sake of solving, I'm just solving. Don't worry if you're not understanding. So just this is how, why I'm discussing this, because this is how we'll be dealing our class in the coming days. Okay, we'll discuss the concept first, and then we'll discuss some few problems which are very important, which covers all the concepts that we have discussed, right? And then I'll give you some assignments, then you'll be solving them, and then we'll be discussing that in the WhatsApp group. That is the general procedure that we'll do. Then we'll do the test series at the end of your syllabus. Okay. So let's say this is our question. So the following data is orthogonal turning. You should know what is orthogonal. Don't worry, I'll tell you. And then you have a diameter of diameter rod on, 100 mm diameter rod, and you want to do this operation on lathe. Then you have a rake angle. Rake angle, where do you provide? On the geometry, tool geometry, single point tool. So let's say rake angle. Let's say, okay, what is given? Diameter is given, that is 100 mm. And then diameter, the rake angle is given. How much is that? Rake angle is given by alpha. It is denoted by alpha, and it is 15 degrees. Okay. Uncut chip thickness is denoted by T1, that is 0.5. Okay. and then nominal chip thickness after cut. After cutting, the chip thickness will be increasing obviously, and that will be 1.25. Okay, it's in mm, and this is mm. Okay, and the shear angle in degrees for this process is 23. Okay, answer is already given. Sorry, this is the answer. I'm sorry, it should be dash. You have to find that, and that is given by pi. Okay, so with this given information, you should be able to calculate the shear angle. Okay, so this is the formula for that. That is tan phi is equal to r cos alpha by 1 minus r sin alpha. We'll be deriving all this stuff. We'll be deriving what is shear angle, what is r. R is nothing but chip thickness ratio, and it is given by T1 by T2. Uncut chip thickness by cut chip thickness. That is 0.5 divided by 1.25. Okay, so how much is this? 0.5 by 1.25 is 1 by, how much is this? How much is this? 0.4. Yes, yes. Okay, and then tan phi is equal to, you know, substitute all the values. That is 0.4 into cos into 15 degrees of your alpha minus 1 minus 0.4 into sine of 15 degrees. Do the calculation and do the phi is equal to tan inverse of the value that you got from that calculation, and that will be pi, and that is given something around 23.31 degrees. So this is how we are going to solve all our problems. Okay, just forget about this. Let's move on. Okay, so we have some conventional machining process. What are those? We have turning operation, you know, all these things. We have face milling. This is what is called face milling operation, right? This is slab milling operation. There is a difference between face milling and slab milling. What is that? You are cutting tool axis is this, and the face is this, right? So both are perpendicular to each other. If you are cutting tool axis is perpendicular to the face of operation, then it is called face milling. And here you are cutting tool axis like this, and face also is like this, and both are parallel to each other. Here both are parallel to each other. If you are cutting tool axis and the face of the milling operation are parallel to each other, then it is called slab milling operation, right? And then you have drilling operation, you know this, right? And then we have grinding operation, we know this also. This is used for finishing, right? Finishing some component to certain degree of surface roughness. Okay, and then there are some things called non-traditional manufacturing process. Anyone who can answer some of the non-traditional manufacturing processes, machining process? Anyone? You can speak up. Hello, guys, are you here? Hello.
Manufacturing process that include laser
Excellent.
cutting.
Excellent. Yeah, you are fine. Laser is one of the answers, and Nandan has answered as water jet, electric. Everything fine. Very good. Very good. So I got some of the answers. Very good. So yes, you're true. Laser is one of the answers, and water jet is another answer, and electric is another answer. So let's see. Electrochemical machining is one of the answers. So you use electricity plus chemical energy to machine it. Till now in traditional, what we are doing, you see, this is tool. This is tool. This is workpiece. Is there a physical contact? Yes. Yes, there is a physical contact between tool and workpiece. And what is the energy? Which energy you are using to cut? You are using mechanical energy to cut this, right? Mechanical energy. Mechanical energy. Here also there is a contact between workpiece and tool. Again, you are using mechanical energy. Contact, mechanical energy. Contact, mechanical energy. Contact, mechanical energy. Conventional. But unconventional or non-traditional, there is no contact between tool and workpiece. You see, is there any contact? So this is the tool. You see, this is the tool here, and this is the workpiece. If you just zoom it and see, there is no contact. There is some liquid in between. Even though there is no contact, you will be able to remove the material. And one more thing is, of course, you can see your tool should be harder than workpiece. Otherwise, it won't cut. But here, That is not a requirement at all. Tool can be anything. It can be very soft, as soft as possible, but still you will be able to remove the material. So there are so many differences between traditional and non-traditional machining process. Okay, so you use electric energy and chemical energy. You use electric energy, electron beam machining like laser, what Aditi was saying, and then you have abrasive jet machining, right? You have ultrasonic machining, you have water electric discharge machining, wire electric discharge machining, and you have laser beam machining. That is what Aditi was saying, and as Nandan was saying, water jet and abrasive jet are looking like same thing, and electricity energy are coming in all of this, right? So these are all non-traditional manufacturing. So we'll be discussing each of them clearly and neatly with schematic diagrams and some math behind it, how the material removal rate is happening, right? And what is the energy that we're going to use, and what are the different materials, and what is this liquid that is being flown, and why that liquid only? What is the use of that? How these chemical reactions are happening? All these things we'll be discussing clearly and neatly. Okay, fine. Let's move on. So next we'll go to the another sector, that is welding. So this definition is a very compact definition for welding. Okay, so what is that? Welding is nothing but it is a process of which localized permanent joint can be produced with or without heat, with or without application of pressure, with or without application of filler material. Three important words are there: heat, pressure, and filler material. Okay. Sometimes no need to use heat, even though without using heat you can join materials. I'll tell you what are the procedures. Sometimes you have to apply some pressure. Once you apply heat, you have to apply pressure. With and without application of pressure also you can join the materials. By just filling, take some 2 plates, keep it nearby and then fill it. Without any pressure you can do that. Sometimes you have to fill some material. Sometimes you don't need to fill any material. Just heat it and join. Okay. So this is a very compact and beautiful definition of welding that I found. Okay, fine. So this is the simple, ways in which the weld joining process have been divided into, categorized into, right? So we have mechanical bonding, atomic bonding. In mechanical bonding, we have temporary and permanent. Then temporary, we have rivets, stitches, tapers, string fits, all the things. All these we'll be discussing in your machine design and strength of materials. But we'll be discussing mostly on atomic bonding, solid state, liquid state, solid liquid state. We have so many things here: arc welding, resistance welding, gas welding, thermite welding, brazing, soldering. All these things we'll be discussing with beautiful, again, schematic diagrams and beautiful, sometimes even videos also will be shown in the YouTube videos, and we will be able to understand clearly what is happening in the process of joining. Okay, next is, these are the different auxiliary skill in welding. You have 2 cylinders. You might have seen this in day-to-day life, right? Then this is a tungsten and gas welding. In auxiliary skill, you have to use filler material. In tungsten and gas, you have to use filler material. And then resistance welding, right? Then there is submerged arc welding. Then there is electroslag welding. Then there is a metal inert gas welding. This is called MIG welding, you say. This is called TIG. This is MIG. So everything is having their unique feature, and everything is having their own importance. Why resistance spot? There is some importance, of course. Why submerged arc welding? Of course, it is doing something good. That's the reason why we are using it, right? Like that. And then let's go into another thing. This is the last one. Let's not bore with so many technical stuff. It's a simple intro session, right? Fine. Forming is entirely different from the 3 that you've seen previously. In casting, you're pouring the material. Even though you're pouring the material, if you go back and see, even though you're pouring material, what is happening? You are wasting this material. This material, this pouring cup, all these things you are putting so that you are filling it. But anyways, you are discarding it. You are wasting some material. And metal cutting, obviously, you are removing the material and you are wasting it, right? And welding, you are not wasting it. You are just trying to join them. But forming, you are taking a material and shaping it. You are not removing any material. So very less material wastage. That's why this is very economy. There's a great achievement in the economy of process. Okay, so this is, you can see, under action of forces, shape and size of metal piece undergo a change. By mechanical working process, the given shape and size of machine can be achieved by great economy in the material and time. So we have categorized as like cold working, warm working, hot working based on the temperatures. You have to know what is recrystallization temperature, what is melting temperature. So based on that, this categorization is happening. Okay. Next. So we have this rolling, we have forging, open die forging, wire drawing, deep drawing, extrusion, right? These are all called metal forming process. These are our bulk metal forming. We have sheet metal formings also, like the punching, blanking, coining, right? These are called sheet metal operations. Okay, deep drawing is a sheet metal operation actually. Okay, because your length to thickness ratio is very, very high, or thickness to length ratio is very, very small. You can say like that. Okay. And then additive manufacturing, this is what the recent syllabus has been added into. So nowadays people are using additive manufacturing everything. They are even building houses also. They're building houses also by using additive manufacturing. Complete house is being built by additive manufacturing. Okay. So what do you have? You have a CAD model first, then you convert into a stereolithographic file. This is called STL file. And then you send it to some kind of a slicing software. It will slice it like this. And each slice is being printed into this in an additive manufacturing machine. It can be anything. There are so many techniques. You have selective laser sintering, fusion, fused deposition modeling, direct deposition modeling. There are so many others. There are so many ways in which we can 3D print it or additive manufacture it. And then you get a product which is not having a good surface finish. Then you do some surface finish operations onto that, and then you get a proper object out of it. So that is how you reach from a virtual product to a physical product. So that is what is your additive manufacturing. We'll be discussing that also. Okay. Fine. So that's the end of your technical part. So I didn't include the industrial engineering part syllabus here because I don't have any figures, because that is full of optimization, math and all. So we'll anyways discussing how to optimize all these things. We have simplex methods, we have graphical methods, we have transportation models, we have sequencing models, right? We have inventory control models, we have PERT and CPM models. All these things are there. We'll be discussing as well of industrial. We'll be discussing industrial engineering as well. Okay, fine. Now, before wrapping up the session, I just want to tell you some. Even though you are joining this institute, I don't. Doesn't matter. The only thing that matters is your hard work. How well you're doing with your preparation. Initially, this is your February. Next year, you're planning for GATE examination. You have exactly 1 year. Then how you are going to deal with that? That is very important, because we are humans, and also in this digital era, it's very easy for us to deviate ourselves in different fields. There are so many different fields. Somebody will come and say, hey, we'll do businessman. Somebody will say, hey, we'll start up some startup man. Somebody will say, hey, this GATE and all is not working. We'll go abroad and we'll do something else there. So everything is, probabilistic nowadays. We can't expect anything can happen in our life, but we have to be sincere to ourselves, and that is one and only one thing that will be helping for us to achieve this kind of a result. Okay, so what I'm saying is that one must be totally motivated, and full curiosity should be there to learn some things. That is very important. Okay, and let's say for an aspirant, let's say for an GATE aspirant, the GATE, they're saying GATE is really a GATE which will lead to a very nice life if you are preparing very well. Okay, so it should be it's not a very short term goal. It's a very long term. 1 year is not a short term, long term goal. Okay, you have to make sacrifices. Okay, you know what, the sacrifices that you made will be evident in your whole life, in your family, generations towards, because if you are doing something good, your generations will happen, they'll keep off remembering, like, okay, this guy has done something during his life, that's the reason why I'm here, like that. Okay, fine. So the thing is, self-confidence is very important. People lose it in between. It's natural that you lose, but you have to discuss, right? You have to converse with your classmates, or maybe with your peers and all, and maintain that spirit, That is what is very important. Okay, so let's see here what is important. First you have to write mock test. Mock test in the sense not now, after exam, after complete of syllabus. Mock test is very important. You're just reading theory, and who cares? In exam there will be questions. So you should be able to solve the question at any cost, and nobody is asking you the solution. Either you are putting right answer or wrong answer. That is important. That's it. Okay. So you have to give mock tests one, and then you complete. Let's say you completed strength of materials. Let's say you completed some engineering mathematics. So so we have to write tests as and when we complete the syllabus. 1 minute, guys. Okay. So then so how you are going to manage the time? So that is very important, because you have 1 year of time. You should not watch. You should not you know what you say, waste unnecessary time. It means that you feel that, like, sir, I'm reading that book which is very important for mechanical engineering. Who told you to read? No. You have to solve the problems. That's it. Okay. And then revision is very important. How we are going to make the revision? So 1 minute, guys. Okay. Yeah. Okay. Done. Sorry for that disturbance. So you are going to revise this daily. So let me tell you one small thing. I'm just crossing the time. Let me complete in 5 minutes. Sorry for that. So when I was preparing for IIT entrance examination, what I used to do is that I used to maintain these short notes for each subject. Let's say for maths, physics, and chemistry, at that time I used to have some different 3 books. In this case, for you keep 4 books: maths, design part, thermal part, and manufacturing part. 4 books are good enough. Make short notes. Short notes means, it doesn't mean that you should write some formula. Of course, you have to write formulas, but you have to make what you say, notes of some theory which you are trying to forget. Every time you keep on forgetting some concept, write that. Let's say you have written some test, and then once you write the test, what you have to do? You made some mistakes, and you repeatedly you're making that mistake, and you don't want to make that mistake. So you write that mistakes also, where you're making mistakes. That is what is short notes. That is your personal short notes. Somebody is writing short notes, you can't take that, because that fellow made some mistakes, and you can't take his mistakes, because your mistakes are different from his mistakes, right? These are all mistakes. Okay, fine. Now, of course, take care of yourself. People, they feel that, like, okay, today I have to read for 12 hours at any cost. That is good, but maintain your health. It's very important. You have to sleep well, eat well, study well. These are the 3 important: sleep, eat, study. That is what you have to do. Then in a time loop concept, what they say is that what you say, they sleep, eat, read, repeat. They say these things: sleep, eat, read, repeat. So that is what you have to do in this 1 year. Okay, fine. And of course, it's like you should avoid food from outside, and all these things you have to take care of. That are all you have to know. And next is, start with your favorite subject. Let's say some people come in, sir, I want to train gate, sir, how do I start? Start with your favorite subject, because it will boost your confidence. You'll feel that, okay, yes, I can do this. So that is where your initial step. The step is important. What you say, read some subjects, and don't read all subjects. This is not your engineering college that you have to clear all subjects. It's not like that. Maybe take 2-3 subjects, parallelly read them and complete them. Okay, and then all these question patterns and all, you have to know that. And standard textbooks, I told you that. And this and all I told you previously. But anyways, the last slide is this. So in the last month, what you have to take, last 1 month and 2 months before the examination, what you have to take, you have to write mock test. Sir, I didn't complete that syllabus, sir. Out of manufacturing, I didn't complete that metrology inspection, sir. I don't read and all. Just make the make one thing, write the test, whatever you know, write it. Whatever concept that you have completed, you write the test. That's it. Don't read some new. This should happen only in the last month of your preparation. Okay. And the most thing people will do is that, like, the unworthy activities, out of context books. No? It will waste your time. Avoiding these unworthy activities and out of context books will save your priceless time and resources as well. Instead of trying hard every time, difficult topics should be discussed with teachers and classmates. You can't crack. I mean, you don't want to waste time. We are here. Don't waste time. Talk to us. Don't you know? There is some lots and lots of reluctance. Some people will they're having some feeling of inferiority. Oh, what that guy will say, what he will feel. I don't know this concept. What nobody will say anything. Nobody knows anything. Even I also, when I started my coaching, I was very, I thought I know everything. Over the period of time, I've learned so many things. Who taught me? You only, students, right? So that's very important. And then the last thing is nothing but the work hard. The only thing that I say is work insanely hard. People around you should get, they should get, you should get crazy. That's it. You don't think too much. What will happen and all, you can take it a talk later. Work hard. So this is one of my famous quote, that is, if something isn't difficult to get, then probably it isn't worth trying for. It's a very nice quote I've been following from 2-3 years. Very important. Please make your time utilized. Once you fix that, okay, I want to crack gate, that's it. Make a good schedule, and for 1 year you have to work hard. And you see, and you won't believe, there are so many people who cleared gate in very nice, with nice score, are in a very good place now, and they are enjoying their privileges as they have worked hard for 1 year. That's it. So out of this complete life, spend 1 year of life and get a very good result and enjoy. So that's my, thank you for listening very patiently. And if you have any queries, I'll be up here for some time. You can ask me the queries. Thank you. Anyone?
Thank you, Naveen sir, for
Yeah.
your session and your guidance. So guys, be free to ask. You guys can unmute and ask if you guys have any query, guys. Aditi, Arvul, Nandan, Santosh, any query?
No, sir. Nothing. Thank you, sir.
No, right. Yeah, thank you.
Yeah.
Okay. So I think